Web servers. Let's talk about that. This is going to be a hands-on approach to web servers in the cloud, particularly AWS, and while there is many ways to host a web server using Wix or Shopify. And now before we begin, I just want to go ahead and give kind of the upfront. There are some helpful things to know when you're talking about web servers, just some Linux basics, some virtual machines in the cloud. You don't need to be a pro in any of these by any means, but this will definitely help you out in this tutorial. You don't need to be an expert, just kind of know what the terms are. So let's go ahead and jump to it. What exactly is a web server? Well, a web server is exactly what it sounds like. It's a server that is serving up web pages or files. These files can be HTML files, CSS files, JavaScript files, and don't be intimidated by these terms here. This HTML, CSS, these are simply documents that have text in them that the computer can read. So your laptop will be able to read this file here and kind of understand what's going on. And when you go to, say, CNN.com or Fox News or something like that, you're actually going out most likely to a web server that is going to send you your computer, your guy, if you're on your cell phone or computer, you're going to get these files. So again, a web server is just a virtual machine, or think about it as a laptop that is sending you these files, these HTML, CSS, JavaScript, and there's many more. And then something else to note here is that there's static websites that a web server can serve up, and that's just the files. So we're just talking the files here. And then of course there's dynamic websites, and that's more what we're used to. And think about like Facebook and these social media giants, YouTube. All of these guys have very dynamic content where you can like stuff and comment on stuff. Perhaps there's a shopping cart or a form you can put information in, and all of that. That is, remember I talked about JavaScript a little bit. When you see JavaScript, you see that a lot of job titles and whatnot. And the language JavaScript is what helps this guy actually send stuff back and forth to maybe what we call the back end, or business logic, or something behind the web server that's doing the actual transaction itself. So what makes a web server is really the software that's on it. A web server is a compilation of many files and folders, and people have put together these neat little packages for us to use as IT professionals. We can then come out and get this software and put it on top of our virtual machine. So the three big players is Apache, and then you have Nginx and Microsoft ISS. These guys are well known in the community, and of course there's many more. And you'll even see like Apache Tomcat, which is a version of Apache, and just there's tons and tons of options out there, which begs the question: well, why is there so many different kinds of software for web servers? And the main reason is because with so many applications online these days and so much different architectural designs, many companies in the early days started to develop their own type of software that was going to be able to serve up the content that they desired to be served. And so the big things to think about is how many web servers do you need? Do you want your application to be able to serve up to hundreds of thousands of clients, cell phones and computers and laptops and tablets, and there's tons of different clients all around the globe trying to connect maybe to your website, and therefore you might need many computers that are going to serve up those files, because one computer just wouldn't be enough. Other things to consider is how fast you want that connection to be and how reliable do you want it to be. And you can run benchmark tests to see how many connections get dropped. Like if a computer is trying to connect to this virtual machine that is hosting all your files and it's trying to send them back, but somehow that connection gets dropped often. Well, that's probably not a very good web server. That's something else to consider. Of course, we have money. That's always a big factor in IT. You have your open source software and then your commercial software that's going to cost money. You have your security to be concerned about. How secure is this guy right here? And many more other preferences that you might have depending on your application. And so all of this kind of plays into what web server to choose and how to go about working with your web server. So let's go ahead and take a look at what we're going to be looking at today. So what are we going to be looking at then today? We're going to be using Apache primarily. This is a very common web server used in some mid-tier organizations. You could even see it in some enterprise organizations, but again, the bigger the organization, you might see a lot of variety of different web servers or certain things like that. It really just depends on the organization that you're working for. But let's go ahead and talk about this, right? So we have three clients. Let's say we have some guy who's sitting on his couch watching a movie, and he's on his cell phone, and we have another gal who's on her computer, and we have another guy, he's actually at the local library, and they're all connecting to, let's say Dick's Sporting Goods. If you're familiar, that's a big sporting store here in the United States. And Dick's Sporting Goods is actually having a big time sale, so all of these guys are coming in to connect to this web server. Again, this is just a virtual machine. and it's hosting an operating system right here, application and OS images, OS meaning the operating system image on an Amazon machine image. This right here is basically this right here. So when you see Amazon machine image, think Amazon AMI. And that is just saying that, hey, you want to use this operating system. You see, AWS also offers you the Windows operating system or the Red Hat operating system or even Ubuntu. But instead of a Windows operating system, or perhaps, I'm sure if we went over here, we'd probably see maybe a Mac operating system or something like that. But we're going to use AWS Amazon Linux here. And then down here, we have our AMI, our actual image that we're going to put on this. So Amazon Linux is an operating system that hosts many different types of, some people might call them distributions, or think about them as images, different ways that the computer can handle that connection. This guy is actually running an Amazon Linux 2 operating system. And when we actually start him, he's going to get a public IP address. And so if you've been in IT a little bit, you know a little bit about IP addresses, Internet Protocol addresses. They get assigned to these virtual machines, and that allows them to kind of traverse the network. And so he's going to get one of those. And of course, it's public is in the name. It's a public IP address. It's public. People can see it. And so, of course, again, we have our friends over here that want to get to this web server, and they will use this public IP address to do so. And then once this virtual machine starts, we're of course going to install this Apache software. That's what makes the web server the web server. Otherwise, it's just a virtual machine. Let's go ahead and do that. Let's actually go ahead and set up our web server. And so the next 2 minutes, I'll just set up my AWS account. If you have never set one up before, now's a great time. You can go ahead and follow along. I went to Google Chrome AWS, and I'm just going to click on the link that looks like I can create an account here. It's going to take me to the AWS homepage, and let's go ahead and complete a sign up form. And so here we go. I'm actually going to say create a new AWS account, and we'll go ahead and do this right now. So go ahead, put an email address. Go in my Gmail, you have this code, here we go, and select personal account, and just fill in the rest of the information. Now here you're going to have to put in your credit card and billing information. I know it's kind of a pain, but don't worry, AWS won't actually bill you unless you click on services that are eligible for billing. And typically you'll know up front how much that service might cost. AWS is pretty good about that. For this tutorial, don't worry about it. We're not actually going to be putting anything on our credit card. This is going to be a completely free trial, but you will have to put in your credit card information to continue. If you feel uncomfortable, that's fine. Just continue watching the rest of the video and get the general gist of it. And they're going to send you a text message saying that's actually you. From here, we're going with 3 tiers. Go ahead and click on that and complete sign up. And this should take you right to AWS Management Console. And so finally, one more time, we can go ahead and log in exactly with that account that we just set up. So I'll go hostcomcyber@gmail.com. And here I am. I'm going to go ahead and put in that password that I just made. And so here we go. We are now in the AWS console. So while it does seem very overwhelming, this is not AWS tutorial, so I won't go through all the ins and outs of it, but this is what your page should look like. You'll have your username up here and then your region right here. Regions are really important because the region is where we're actually going to, what we call deploy, or where we're going to put the virtual machine itself inside of the cloud. And inside of these regions, there's availability zones, and think about those as actual buildings that are hosting these virtual computers, or these computers themselves, right? So let's do Northern California for right now. Click the region closest to you if you'd like, or if you want to follow this tutorial exactly, feel free to go Northern California. With what we're going to be doing, it doesn't matter as much. Maybe some latency, and that's just the time it takes for your computer to get to the actual connection. But let's go ahead and do that. So we're in Northern California now, and we've clicked on instances. Go ahead and click on instances again, or you can even type in up here EC2. And this is another way to get there. You can go EC2 and instances right there. So here we go. We have our instances spinning up right now. And there are no instances, of course, because we have not set up one. So let's go ahead and do that. This big fat button right here, launch instances, or this big fat button up here, launch instances. Either one of them will get you to this next page. So go ahead and click on that. And here we go. We can now name our instance. So let's actually name it. I mean, they do a great job right here. My web server. Let's call it that. My web server. And then here we go, our application OS. Remember, we saw this image earlier in that PowerPoint, and this is the operating system, the AMI. So the Amazon operating system in our AMI. Let's actually just do Amazon Linux 2. This is kind of the newer version, a newer kernel, and it's going to give us a little bit of, you see this SSD volume type. It's going to give us a little bit of storage. Think about that as you plugging in a USB stick or an external hard drive into your computer. We'll go ahead and 64-bit. x86 there, verified provider, that's always good. Verified provider is just saying that, hey, Amazon did make this operating system image. So let's go down here. We have T2 micro. Now this is interesting. This is the instance type. So I know it can get a little bit confusing because it seems like we're doing a lot of options here. So this is our OS. This is the image of the OS, or the distribution, if you will. And then our instance type is the actual size of the computer. How big is it? And of course, we can compare instance types here. You don't have to click on this, but just to show you kind of what is really going on here. So we have vCPUs. These are virtual computers, and so we can go all the way up to, a typical maybe setup might be you have 8 virtual computers with 16 gigs of RAM. But I mean, there's a ton of choices here. But to stick with simpleness, Let me cancel out of this. We're actually going to stick with the T2 micro that is free tier eligible. Free tier eligible. That's what we want. So very, very tiny, tiny virtual machine. So we're not going to be hosting crazy, crazy amounts of data on this web server, but we can still get by with this T2 micro. So key pairs. This is really important now. Key pairs is how you're going to get into your actual virtual machine. Back to our slide deck here. And so we have these two options. We have RSA and this ED25519. And RSA is developed by these three guys right here. I'm not going to try to pronounce their names because I'll probably mess them up. But essentially, they developed this encryption algorithm with a very long key, larger keys, a lot of bits when it gets all encrypted and jumbled up into a different language. We come back over here to ED25519, and this is kind of under the family tree of elliptical curve cryptography, ECC. And these are about the same size keys, if not a little bit smaller than RSA, and they're computationally efficient, and these are really, really good for lightweight devices to be, I'm not gonna say the standard, it just depends on your use case, right? So this is bigger keys, well known, smaller keys, gaining in popularity, I should say. And so that's the difference between these two guys. And then we come down here to PEM and PPK, and the PEM file is for your privacy enhanced mail, and you're gonna see oftentimes something like this, begin certification, and then your encryption key inside of there, and certification. And we'll look at this file here in a second, actually, when we finally jump into the virtual machine. I'll take a look at this. And then, of course, we have our PuTTY private key, our PPK, and that's going to be primarily for Windows. And if you know PuTTY, you know what I'm talking about. It's a very nice GUI, easy to click around and get into your virtual machine, or SSH, Secure Shell Protocol, into that virtual machine. And we're actually going to name our key pair my web server keys. My web server keys. I'm going to use RSA and a .pem file for this tutorial, but feel free to play around with this and get familiar with different types of keys. So now let's come down here to network settings. Again, there's a ton to this. I don't have time to explain it all, but you have a virtual private cloud. Think about it as like a LAN inside of a building, a LAN area network. So inside of your building, you have your one network, and then of course you can peer these VPCs and manipulate this to a degree. And for our firewall rules, we're actually going to create a security group. Think about a security group as exactly how AWS said. It's like a firewall. So on our computers themselves, any traffic coming in and out of those computers needs some type of a check, I should say. And the internet runs on these protocols, these fancy terms like you'll hear SSH or HTTPS or HTTP. These are all really good protocols to have and know about, and they will take you very, very far as security goes in setting up your web server. Now, of course, we have configure storage. We're not going to worry too much about this, and if you have advanced details. Advanced details, well, to tell you the truth, this is advanced. There's a lot in here to wonder about, like, how you want to stop your machine or shut it down. So there we go. That's everything, kind of the basics, the bare bones of launching an instance. We can do a number of instances, and if you're interested, you can do 4 instances, and then later, if you want to do some load balancing, you can actually, have your load balancer, and I'll talk a little bit about this at the end, split your traffic to go to 2 VMs and then 2 VMs, and those are in target groups. So think about, like, you could launch 4 instances and then divide them kind of in half, like where 2 live in A group and 2 live in B group, and as the traffic comes in, you can imagine, the traffic's here, and then some's going to A and some's going to B, and that kind of provides you that redundant, fault tolerant, you'll hear those terms thrown around. But right now, let's just do one. We'll just do 1 instance. And here we go. It even tells you right here, free tier in your first year. It includes 750 hours. I think that's 2, maybe 3 months or so of T2 micro. And then if you have all this extra knowledge here that Amazon's going to give you. So let's go ahead and launch this instance now. We're launching it. It's creating the security groups. And so we have details, our instance ID. We have our host name. Auto-assigned IP address, which, our auto-assigned IP address, you see public IP address, it's also just right here, public IP address, they're the same thing right here. And we have all this information that we can glean from our web server that we're about to set up. So it's not technically a web server yet, it's right now just a virtual machine. We've named it a web server, but it's not yet. Okay, so now we've set up our instance. Let's try to SSH into this guy right here. And we'll actually, let's go ahead and use our key that we just set, this .pem. Remember, we set up a key pair. And so one of the keys is actually on the virtual machine, and then we're going to receive the private key. We've held on to the private key. And I'll show you this one because I'm about to delete it. But before I show you it, please, please, please do not share this key with anybody. Don't share your private key. That's bad. That's very bad. You get slapped on the wrist for that. So remember, my web server pem key. Let me just open this with Notepad, and you'll notice all this jargon here, and this is just an encrypted version, some mathematical encryption that happened when we did the RSA. This is the encryption version, and if we did the ECC or the ED255, I think it's I don't know the rest 1592. That would be a lot shorter because remember we're talking about bits and how it gets encrypted. But this is the RSA key here, my Webserver keys.pem file. And so let me come here and a little shortcut. If we just type in cmd, we'll actually be opened up with a command prompt inside of this directory here. So let me minimize this so we can see there is our private key there, and here is our public key here. So let's SSH, and then to pass in this private key, we'll have to do a -i, and this is saying, so go ahead and SSH in -i, and then my web server keys here .pem. I just push tab. You could type it out. You could type out my -web servers keys .pem, and that'll say, hey, when I use this SSH command, go ahead and give me SSH using these keys. And then we'll go ahead and EC2-user. And of course, we got that from, if we look at the Amazon documentation here, with this default user, EC2 user is the default user for this operating system. We didn't set one. But we have one now because Amazon is kind and gave us the default username being the EC2 user. And so now we take this IPv4 address and we'll put it at the end. So this is the proper syntax. There's no real easy way to just kind of know this. There's a ton of documentation online that will probably tell you how to do this. But there it is. The SSH, we'll pass in our key, and then we'll use the EC2 user and the @ symbol saying where do we want to use this user at, and we want to use this user at this address. And so let's go ahead and connect now, and here we go. 6 packages needed for security out of 13 available. Run sudo yum update, which we will do right now. Sudo yum update. That is Amazon telling us. So look, we did this. It gives us a nice picture of a bird. It says we're running Linux 2, some other end-of-life information, and the newer version of Amazon Linux is available. A newer version. Remember, this is 2, Amazon Linux 2. This is a newer version, and then it tells us to run this command because there are some updates that are needed. So let's go ahead and run this command. And we will most likely have to tell our computer, yes, do you want to add this? Is this okay? Yes, it's okay. Type Y and enter. The sudo yum update to -y. Well, the -y was just saying, hey, go ahead and push yes for me. We didn't actually do the -y. We just did it and then said yes to the system. But let's go ahead and now install our Apache sudo yum install HTTPD sudo yum install Apache D-Y, and we get a rolling update. So we went up to the repository, and that's what we're doing now. Let me actually bring this over here so you can see now both side by side. So we just did that guy, and here we are. So now we'll go sudo system ctl start HTTPD. So you can imagine, you can suspect what this did. We said, hey, root user. Our system here, the very virtual machine that we've jumped into. Remember, we were running from our computer, from your laptop, and then we jumped into another virtual machine. And now inside of this virtual machine, we are running commands locally here as if we were them. But now root user systemctl on this machine. Go ahead and start my Apache server, and then we'll actually enable it. So sudo systemctl enable HTTPD. And this created a symbolic link, the symlink. It created a symbolic link from here, from this whole directory, to here, to this whole directory. And what that did is it told the system every time you reboot, make sure that this service is running. So this is nice. We could have stopped here. This would have started. But if we restarted our system or shut it down, HTTP or Apache, the very web server, the very files and folders that we'll see in a second, would not be there if we shut it down. So enabling it says, hey, go ahead and create me a symbolic link to drop it in a directory, which always will restart this service. And then finally, we'll go system and we'll check the status of it. So sudo systemctl status HTTPD. And there it is. The status, it's active, it's running. Our web server is charging forth and doing great things for us. And all we did was just, we just installed it with 1, 2, 3, 4 commands, and it's that simple. So now let's check it out. Let's look at what's there to see in this service here. So let me do this. Oops, not that. No, I don't want to do that. Let's try this. So what's there to see in this service here? Well, for starters, we'll look at the web root directory. And so cd, remember, change directory into the var www/html. And if I go ls here, well, there's nothing here. There's nothing here. Ls is a longer version of it, and there's nothing to be seen here. So we've changed into this directory. We've jumped to another folder, and then we've listed out the contents of that folder, and there's nothing to see here. But we can see that we can place all of our website files here, or our assets, and this is going to be our index.html. Remember from the first thing, we had our .html, our .css, our about, maybe if we have an about page, some dynamic JS content perhaps, or some pictures, and we can create a kind of an even further directory inside of here with images and certain folders and whatnot to populate the web server, because right now there's nothing here. It's running, it's active, but there's nothing here. And if you're an actual web developer and you have an index HTML and whatnot, you would know how to get your files onto here. But right now we have nothing in here. So the fastest way to really do this is to, you could copy and paste. You could do a sudo vi, and you could come into this directory, this var www.html index.html, and you could paste, copy and paste your content into this. You could secure copy your files up. These are both free options to do, and you would actually, again, pass in your -i, you would pass in your PEM key, and then you would find your local file here in EC2 user and put the destination, and then put the actual destination of the directory here. You could put it in an S3 bucket, and there's some steps to do that. That's a little more advanced, or you could use a full-blown CI/CD pipeline, and that's very expensive, and there's a lot to this, but you could do that as well, and those are all ways to get your web server's content up to date. And there's many more as well. These aren't just the only 4 ways, but some common ways to do that. And so in the YouTube description here, I'll put the link to the GitHub, but here's the GitHub, the Wholesome Cyber basic website page here. And let's just pick any one of these, right? Let's do our index.html, and we would select this index.html, and we have all this content here. And this is just a basic resume. If you wanted to spruce up your website and host your resume here, you could use this index.html default resume. And let's come back to our, so we'll go ahead and copy this. So, and now if we actually just do a sudo vi index, and we're going to give it a name, index.html. So we've said, hey, root user, use this text editor, this vi, or maybe you're using nano, and give it a name called index.html. And then we'll come in here, and I'll push I for insert, and then paste. Anyway, I'm about to paste all this content. Let's paste this HTML, and let me escape, :WQ. And AWS makes it easy. We can just open the address. We'll just open that address. And here it goes, it's loading. No, it didn't work. But why? Well, remember, we talked about security groups. We're trying to get to it using HTTPS. Let's see if we just change our port here, and there we go. We changed it to HTTP. We put the port 80 at the end of it, and here we go. Our index HTML is now showing. I don't like this. So let's go ahead and actually add one more called CSS. Let's try this again. Let's go sudo vi, and we will call this one our style.css, our style CSS. And let me go ahead and just Control A, and we'll copy this, and we'll come back over here, and we'll call this style.css. So the same name here, style.css. And I for insert, right mouse click for pasting, escape, :WQ, and here we go. Now we have 2 files. We have 2 files in here. And if I come back to our web page, and let me do F5 for refresh, or you could refresh the page. And wow, this is amazing. So much better. We finally arrived at our wow, our website looks amazing. Very good. If you're still with me, very good. This is awesome. And so finally, the final kind of tidbit I want to show you, we have our web server running. We wanted to talk about our load balancer. Remember I said you could have deployed 4 things in there. Well, let's go ahead and let's look back at our Amazon. And this is some homework for you. If we actually shrink this, and you can shrink the rest, even shrink autoscaling here, we have our load balancer. We'll talk about autoscaling group. We have our load balancer. And if we had more instances, right now we just have the web server. But if we had more, we could actually do target groups. We come in here and create a target group. And this is homework. This is homework for you if you really are interested in this stuff. You can actually choose your target group, choose the target type that you would want. And you would say, yes, I want an instance, or maybe you want an IP address range, and get really kind of freaky deaky with this stuff. And then theoretically, this is kind of how it would look. You'd have your clients, and they would, instead of going directly to the server, they would come to your load balancer, and your load balancer would handle these connections. This guy would handle these connections and secure it. But you don't have to do necessarily all the patch updates. So some of the security Amazon will take care of, and we'll go ahead and send the traffic to the corresponding servers. And if things get bigger, your little retail website that you're hosting is booming, this will go 3, maybe 4, maybe 5, and I'll send your traffic to the back end. And these architectures can get very complicated, which is why I won't go too much into it, but you get the idea here. Well, that's it. That is what Webserver is in a nutshell. I hope you found this interesting. If you have any questions, please leave comments below. I'll be happy to address them. If I've misspoken and you have some seniors on this video, please let me know. I would love to get better. Well, I hope you have a wonderful day, and remember to stay wholesome.